When you're on your deathbed, you want your primary emotion to be curiosity rather than regret. One of my very few regrets in life is routinely eating Captain Crunch cereal as a bedtime snack during the 1970s. That was before dental sealants, so I have fillings in several of my molars. I hope to keep my teeth for life, but I'm a little worried each time I eat a healthy snack like raw carrots that I'll break a tooth. I'm Professor Mark Hinders, Applied Science Department at William & Mary. X-rays are routinely used in dentistry. They work really well for some things, but they don't work very well for cracks. Visually, you can't tell the difference between a surface craze, which doesn't matter clinically, and a deep crack that's going to break off a piece of your tooth the next time you bite down on a carrot. CT scans are used sometimes in dentistry, particularly cone beam CT. It can make beautiful 3D images of the internal structures of teeth. Here, let me show you one. The issue with CT scans is partly expense, but more importantly, the radiation dose involved in them is, in some cases, worrisomely high, so they aren't used routinely. We've been developing ultrasonic techniques for finding cracks in structural materials for many years. We even pioneered a technique called Lamb wave tomography, where Lamb waves in thin plate-like structures, for example in aircraft, go back and forth across a region of interest and interact with any flaws in there and locate and size and otherwise characterize the flaws in the region of interest. Here's a clip from a thing we did for History Channel some years ago showing one of our systems in the laboratory.
Yet perhaps the most important result of the accident is that it draws attention to the potential problems that can occur to high-cycle aircraft. Future inspections may be performed by high-tech ultrasound equipment like this, which is designed to detect corrosion and fatigue cracks under an aircraft's paint.
One of the things that's fun about what we do is we get to understand the physics of the measurement, for example, Lamb waves, and develop new measurement techniques to solve particular problems. And so, one of the techniques that we use with ultrasound guided waves is called acoustic microscopy. And acoustic microscopy uses particularly angled incident waves to a surface and then picks up the reflections at some other angle, so in and then back out, and we get a little propagation of a so-called Rayleigh wave along the surface, and that's very sensitive to small cracks in the surface. And this technique, acoustic microscopy, works very, very well for very small sorts of flaws. So we have been thinking of configurations of using Lamb waves in order to detect cracks. And we had previously developed a Lamb wave technique for inspecting pipes called helical ultrasound tomography. And so we know that you can propagate guided waves around a pipe and detect flaws all the way around the circumference. So we got to thinking, could we adapt this to finding cracks in teeth? Okay? So the idea is that we use an angle block delay line that launches Rayleigh waves at the right angle so that they will, the Rayleigh waves will go circumferentially around a tooth. And then we pick them up when we come back around the other side with a handheld transducer fixture handpiece that could be used in a dental office. So you touch it to the surface, it launches the ultrasound waves that go around the tooth circumferentially, pick those back up when they come around the other side, and if there's a crack anywhere around the circumference, including between the teeth where you can't see it, that will disrupt the propagation of the Rayleigh waves, and that will show up in the signal. The other thing that happens in acoustic microscopy is there's this really interesting interplay between a direct reflecting wave and the Rayleigh wave path. and that the interference between them gives incredibly high sensitivity to minor flaws. And so the scheme that we wrote a patent application for uses this combination of the circumferential surface waves and the direct reflected bulk wave in order to get maximum sensitivity to cracks in teeth. It's an interesting concept. We've sent a patent application through the system, which was published but hasn't issued, and we've done the preliminary work in the laboratory showing that the measurement concept works quite well, both on locally flat things and on round things. We've also done simulations and other studies of this to verify that the measurement concept is sensible. The advantage of ultrasound techniques in dentistry is twofold. One is higher sensitivity to the cracks, in this case, that you care about, and the other one is ultrasound is non-ionizing, it's perfectly safe, so there's no issue with the measurement technique ultimately causing some disease. I'm Professor Mark Hinders, Applied Science Department at William & Mary, as.wm.edu.